10, rotating systems, part 4, angular momentum. Angular momentum. A moving object has linear or translational momentum given by P equal to mv that you've already learnt. A rotating object has angular momentum given by L for angular momentum equal to I for rotational inertia times angular velocity. The unit of angular momentum, L, is that. Conservation of angular momentum says provided there is no external torque acting, the total angular momentum of a system remains constant. So notice, instead of saying no external force, he says no external torque, which is important. For this example here, we have a turntable spinning freely with an angular velocity of that much, 4 radians per second, and you have to find out the angular momentum of the turntable. And then if a disc is dropped onto the turntable, what is the new angular velocity? Question A, using that formula, simple enough. But for question B, you have to use the principle of conservation of angular momentum, where it says the initial total angular momentum is equal to the final total angular momentum. And you work through and you get that. Here we have two examples of angular momentum. This girl here is spinning herself around on one skate. Here we have a helicopter, and this is the tail rotor to compensate for the torque produced by the big rotor. Otherwise, the body of the helicopter will rotate the other way, equal and opposite. Linear momentum turn into angular momentum. Here we have a blue object with a linear momentum of mv. Its mass is m, his velocity is v. When it joins itself to the rim of this round object, it will impart or give a rotational momentum to the round object given by L equal to mvr. mv is simply the linear momentum times that radius there. Here we have a child running onto a merry-go-round. The question is, what is the angular momentum imparted by the child? And you just use that formula straight, and you get the final answer of 25.5 kilogram meters squared per second.